check your work with my work. Comments, questions, concerns. Oops, someone's using my Netflix. It's probably my sister. Okay, hands up, questions, comments, concerns. Hearing nothing, sliding up. Yes. You don't have the sheets. This is tragic.
Where is what I need to give you? How do I not have extra sheets? Oh, I do. Right. I will. 1 second.
Okay. I just had it open. Gavin, for you, and only you, special Gavin. A freshly printed, straight from the printer, it's going to be warm if you rest your face on it, note pack. He's very lucky. He has to wait though, so he's unlucky. Bam. Come on, computer. You can do this. I believe. I will, yeah, give me 1 second. Check your work and I will go over. I just need to print this for Gavin. Okay, so there's way too much chattering going on. Comments, questions, concerns from anything on this first page? Hands up. Nick, I see that hand. Part 2, question 6. Converting a decimal number to a fraction. This bad boy? What do you mean you get 2.5? Oh, 2 and 1/2? It's the same thing. Yeah. Any other questions? Shyla, didn't you have a question? Wasn't there a question you guys had? Someone wanted me to do something on part 6? Or part 5? You were just about to ask me a question. No, we're good? Okay. Okay, then hearing nothing, flipping the page. Yeah? There's that. Okay, grade 9. There's way too much conversation happening. Just check your work. Oh, Gavin, that's you. There's 79 pages coming out. So, just so you know, you have to stand there and wait. But I would certainly go stand there. Yeah, just go hang out there. It'll be pretty quick. Okay, who we got? Who's back? Is Olivia back? Olivia, is that you? What fictional animal would you want to have as a pet? A little pony cat. Is Jasleen here today? Oh, Jasleen. Fictional animal you want as a pet? What kind of dragon? No, there are many. Like Smog, like gigantic fire-breathing flying dragon, or like Toothless, or like Mushu from Mulan, or what are we talking here? Toothless. Okay. So Chelsea's just the only one downstairs still. Okay, cool. Okay, sliding this thing up further. How many of you didn't read the instructions on this top question and you actually started rounding things places instead of telling me what digit was in there? You all read instructions properly? Awesome. So a few students do. Sliding this up further. There's the end. Comments, questions, concerns on any of the rounding questions? Going once. Going twice. Going 3 times. Sold. Okay. Oh, we weren't done? Did you finish the work? Or are you just checking it? Okay. Is there a question? Okay. So then y'all. Our photocopier is kind of working. And by kind of working, I mean this. I was able to print the entire rest of the chapter. And I told it to hole punch. It photocopied and stapled beautifully. Unfortunately, it hole punched like an idiot. And the holes are like askew. So for those of you who are going to put this in your binder, I'm sorry in advance. I did not do this on purpose. But I didn't discover this until I had finished photocopying, and I'm not re-hole punching this. Or re-photocopying this. Because while this is a lot of paper I don't mind using, I'm not doing it again. So I apologize in advance. This is going to suck when you put it in your binder. But and I'll make sure the next one's not, terrible. If you want to hole punch it again yourself, you're welcome to. Gavin, can you take the hole puncher and put it on top of that computer tray that's there? Yes, the hole puncher should be back there. Yeah, that guy there. No, put it on in front. That grade, yeah, right there. If you want a hole punch after you get it, you're welcome to do a re-hole punch. Okay, and pass straight back. Take one, and it's the whole shebang. I know, it's coming. Put it back in the car. Give me a second. Thick with 2 C's. 2 C's. Okay. Okay, Carmen, you have a question before you get up? Yes. Yeah? To the nearest thousandth means you need 3 decimal places. The 5 is in the hundredth space. 10th, 100th, thousandth. Okay, here we go. So, I overheard several of you last day when I think I mentioned we were going to square roots. I can't remember how it came up, but I overheard the discussion about not remembering how to do square roots. So this will be a great little time to review, and we're going to do some new stuff now. Yeah. Oh, before I should pause this video because I don't want. Okay, again, love it. Okay, grade 9s, I need you, now we've all hole punched, have a seat. Oh, we've almost all hole punched. Okay, hands up, square roots. Positive numbers always have blank square roots. Rebecca says 2. Rebecca is correct. 2 square roots. 1 positive square root, called the principal square root, which this is probably the last time anyone's ever going to use that word, and 1 negative. Do we understand how a square root, the square root of a number could be negative? We don't. Okay, so that's new for some of you, not new for others of you. So, let's talk about what a square root actually is. Square root symbol, what is it? It's like division, but it's a little more spikety. Looks like that. Okay, it's a mathematical operator. We're going to look at a whole bunch of those this chapter. Yeah, there it is. Mathematical operator. That does what? What does that operator do? It does not divide. What does it do? Nika, brilliant. That doesn't actually help us, though. Yes, sir. No, it itself does not. We might have to simplify with it, but what does it do? It doesn't divide evenly, because that's division by 2 is it dividing evenly. Danny.
Like it finds the number times itself that equals the number.
Okay. It's a mathematical operator, thank you, Danny, that takes a number in and returns, or gives you, I should say and, the number that multiplies by itself to give you the original number. I know it's wordy, there's a lot there, but this is what a square root does. It takes in a number, you give it a value, and it will return to you the value that, when multiplied by itself, will give you the number that it gave. That will give you the number that you gave it. There's lots of gives and its and yous and thems, but that's okay. We'll do an example. Maybe it'll make sense. So, I want to take the square root of 16. What is the square root of 16? We have given it a number. You put a number in, 16, and this operator is going to give you the number that multiplies by itself to give you the number that you gave it. So what multiplies by itself to give you 16? Carolyn? 4. That is one of the acceptable answers, because 4 times 4 is positive 16. What is the other totally acceptable answer? Presley? Negative 4. Because if I have negative 4 times negative 4, and negative times a negative is a positive, and 4 times 4 is 16. So when you take the square root of a value, there is always going to be a positive and negative square root. Sometimes we write this as, so the square root of 16 is equal to plus or minus 4. We write it as a plus or a minus stacked on top of each other that way. Hands up if you've seen this kind of notation before. Some of you, not very many of you. That's okay. Do we understand what this notation means? We cool with the plus and minus above each other like that? Sort of. Mathematicians are inherently lazy. The ultimate goal of mathematicians is to do as much work as humanly possible in as little space as humanly possible. You're not mathematicians yet, so you still got to show me longhand. But they'll say, okay, well, instead of writing 4, comma, negative 4, I can just write this, 4, plus and minus. And the understanding there is that our answers are both the positive and negative versions of that number. That's what that notation means. So let's do another one. Actually, where do I do this? Do I do this somewhere else? I do this somewhere else. Do I do this? I do. Okay, so let's do another example. Square root of 64 is? Is it just 8? It's plus and minus 8, or positive and negative 8. Both those does. Unless I specify, just give me the positive root or the principal root, you should start giving both. What makes 16 and 64 so special?
Good morning, grade 9 students. Last name T, U, and V. Please head to the library to see the nurses.
Rebecca Cheyenne, good luck. Okay. What makes 16 and 64 special? What do we? Why are they? Yeah. What makes them special? Danny.
No, that was I don't know.
Oh, that was your gesture of I give up.
First floor students, please head back to class for instruction. Second floor students, please wait for the bell to begin your lunch.
16 and 64 are special because their square roots are whole numbers.
Oh, okay.
A number that has a square root that is a whole number, we call a perfect square. So a perfect square is a number with a square root that can be written as an integer or a finite / infinite repeating decimal. So, which of the following are perfect squares here? Four is, yeah, let's circle them. 4 is good because the square root of 4 is plus or minus 2. What's the square root of 8? Okay, it's not. Okay, so 8's bad. How about 12? No, how about 16? Yeah, because its square root of 16 is plus or minus 4. Okay, good. 25? Why is 25? Because square root of 25 is 5 times 5, which is plus or minus 5. How about 40? 49? Yeah. Root 49 is equal to what? Oops. Plus or minus 7. Yeah. How about 64? Yeah. Okay. Plus or minus 8. 81? We like 81. Okay, why is 81 good? Plus or minus 9. Okay, cool. How about 0.5? How about 36? Oh, sorry. How about 0.36? Is 0.36 a perfect square?
Yeah.
Who said yes? Carolyn and Danny both said yes. Danny, why do you say it is?
It's 6 times 6 is 36, but I don't know if it.
So 6 times 6 would be 36, but I don't have 36. I have 0.36.
Yeah.
0.6 times 0.6. Well, someone said 0.06 times 0.06. What's the okay, so which one is it? Let's take a look at 0.06. Let's go longhand and take a look. How do I multiply decimals together? Have we done that already, multiplication of decimals? Am I going to do that later? Let's see if we do that later. Oh yeah, we're kind of going to do that later. Didn't we do that already? Oh yeah, we're going to do that later again. Okay, how do I multiply? Review. Go, that's good. That's good sound. Oh, we'll review when we come back from lunch. Have a good lunch. See you in a bit. So we've established that it is, and we're just trying to figure out what multiplies by itself to it. Before a bunch of you left, I heard you discussing it, and some of you figured it out. But so what is it? 0.6 or 0.06? Which one of those is the square root of 36? Hands up. Yeah, Nika. 0.06. You're doubling down on 0.06? Okay, let's do it. What is 0.06 times 0.06? How do we multiply decimals? Well, we're going to prove it right now, what it is. 6 times 6 is 36. And when we multiply things with decimals, our final answer has to have, or what is the total number of decimals our answer has to have when we multiply decimals together? No. When we multiply numbers with decimals, how do we determine how many decimal spots are in? Hey, what? Which? Yeah. Okay, how do we determine how many decimals are in the final answer? Okay, ladies who are coming back late, no talking. Gentlemen at the back. Shh. Okay, sorry, it was being discussed. Yes. No? Carmen. Okay, so I got 2 and 2, which is so 4 decimal places. For my final answer, then I start at the right. 1, 2, 3, 4. There's my decimal. I fill in the spot. So 0.06 times 0.06 is 0.0036. Same thing, 0.6 times 0.6. Multiply those together. That's going to get 6 times 6 is 36. 1 decimal place there, 1 decimal place there. Add those together. Means my final answer has 2 decimal places. So the square root of 0.36 is going to be plus or minus 0.6. That is a finite decimal. Finite means it ends. And a finite decimal, and the finite decimal is 0.6. Things get a little bit weird when we're multiplying decimals. We got to remember how that rolls. 36 over 9, is that a perfect square? Is 36 a perfect square? Is 9 a perfect square? So that I could rewrite this. 36 can be written as 6 times 6, and 9 can be written as 3 times 3. So what's the square root of 36 over 9? 6 over 3. But 6/3 is just what? 6/3 is just 2. Because what's 36 over 9? 4. So if you'd reduce the fraction, if we'd reduce the fraction first, 36 over 9 is just 4, we would have seen right away that that fraction is a perfect square. But one of the fun things about square roots is if I want to take the square root of a fraction, all I have to do is I have to take the square root of the numerator and the square root of the denominator. We're allowed to do that. Square root of 36 is 6, square root of 9 is 3. If the top and bottom are both perfect squares, the whole fraction is a perfect square as well. And as always, this thing is plus or minus. Comments, questions, concerns? Is this bringing back memories of square roots? Is this brand new for anyone? For a few of you? We didn't do any square rooting in grade 8? Okay. Okay. Pretty sure you're supposed to, but that's okay. It's not your fault. Square roots that cannot be written as an integer or a finite slash repeating decimal are called imperfect squares. Well, I guess I should also, or a fraction. Fractions are allowed too. Are called imperfect squares. And we have to learn how to deal with the imperfect squares. Imperfect squares are what's going to cause us a whole bunch of problems. So there's going to be a couple different techniques that we're going to look at to deal with these. The first one is a crash course on estimation. Now, I am going to be the first to tell you that estimating a square root is very rarely something that you're going to be asked to do. It's not one of those things that's abundantly useful. If you asked me right now, when in my life am I ever going to estimate a square root using the techniques that I'm about to show you, I will tell you never, unless you become a math teacher and teach it to another group of Honors 9 students. You will never do this. But the purpose behind teaching you stuff like this is more than, this is not just a regular math class. My goal is not just to teach you enough to get by and survive in this world. My goal as a math teacher, especially because you guys are effectively taking an honors math course, is to force you to learn some new techniques that even though you might not use, will force some mental flexibility. They're going to cause you, that's my goal. I want to expand your mind. I called it before, math is a performance art, right? And so you only get better at it by being forced to exercise a particular muscle. So this is one of those techniques that you're not going to see it again outside this class, but we're going to teach it to you now. So we can estimate square roots of non-perfect squares without a calculator. And then we're going to, a number line is going to be intensely useful. And trust me, after I force you to estimate for a little while, I will actually teach you something useful that we do with roots that's going to be absolutely a skill that you need to carry forward. So here we go. Estimating square roots. There's a technique for estimating square roots. First, what we want to do is we want to find the closest square roots.
Attention
No,
grade
I lied.
9. This is the last call for any grade 9, whether they have a form or not, to please see the nurses in the library for immunization. All grade 9s who have not yet seen the nurses, please go to the library. Also, could the ISP 10 class report to the library? That's ISP 10. Thank you.
Okay, so anyone who's not got vaccinated, go get vaccinated. Sorry? Oh, you want that? Yeah, sure. You've not seen the nurses? Go see the nurses. Vaccines are awesome. Find the closest perfect squares above or below. That's the technique we want to do here. So, what are the closest perfect squares? So the closest above and the closest below to 50. 49 below. And above? 64. So squared 50 is going to show up over here somewhere. That's our first thing we got to do. But we're not interested in 49, 50, and 64. What are we interested in? Danny? We're not interested in 49, 50, or 64. What are we actually interested in? I don't care about 50. I care about, we're interested in the square root of 50.
Yeah.
So I'm going to take the square root of all three of these numbers. And so our value for our estimate of root 50 is going to land somewhere between 7 and 8. It's going to be closer to 7 than it is for 8. What we have to do now is we have to figure out what fraction of the distance 50 is between 49 and 64. And here's how we do that. Second step. Find the, and I'll put it in quotes, distance between the perfect squares. And while we're at it, we're going to do step 3 right away. Find the distance, quote that again, between the lower square and our value. So here's what I mean. 49 and 64. What is the distance rather between these two numbers? No, sorry, between 49 and 64, not between 7 and 8. Sorry? 15. Cool. And what's the distance between 49 and 50? 1. So 50 is 1/15 the distance between 49 and 64. So our estimate now is going to be 7 and 1/15. Does anyone know our 15th fractions? I don't, so if you did, that'd be really cool. We don't know our 15th fractions, so what we're going to do here, our last step, because the reason we're estimating is because we don't necessarily inherently have calculators in front of us. Step 4 is we're going to, and I'm going to put this in quotes again because this is something we don't typically do with numbers. We're going to massage them. You'll understand what I mean here in a sec. Massage the fraction. Trust me, it'll make sense. To find one close and simplifiable. Okay, so we're going to massage 1/15. It's kind of weird. So what is a fraction that is close to 1/15 that perhaps we could simplify a lot easier in our head? One-tenth, 1/15 and 1/10. It's close, but can we do better? I mean, a tenth is closest. If we go with, who suggested a tenth? Okay, if we go with the tenth, I say, okay, well, this is 7 and 1/10. If that's our close fraction, that means our estimate is going to be 7.1. Hands up if you got a calculator handy. You know what, let's do it this way. Someone get a calculator handy and find out what the square root of 50 is. What does your calculator say the square root of 50 is? Let us show you. If you don't know how to use it, okay, everyone grab a calculator. Let's show you how to use it. Everyone grab your calculator. So who's got, what kind of, who was, yeah, let's start with the sharp. Who's got the sharp calculator? Okay, so to find a square root on the sharp calculator, it's this button right here. You can see that root sign right there? That's that guy there. So we're going to find the square root of 50. 7.07. That's pretty good. Now let's figure out how close our original estimate was. We said 7 and 1/15 was our estimate. So 7 and 1/15, that's 0.06 repeating. That's a pretty good estimate. 7 and 1/15 is a pretty good estimate, but we can't do our 15ths in our head necessarily. So that's why we're going a little bit off board here. So if the square root of 50 is 7.07 and our estimate is 7.1, I don't know, I think that's pretty good. Is there this? I'll show you this calculator. Hands up if we roll on this calculator. What? Not very many of you. Okay. Do we know how to use the square root on this one? Ty, you've done it before? Okay. Well, I'll show you all anyway, for those of you who may have not. The difference between the previous calculator and this one is this calculator doesn't actually have a square root button. What you have to do on this calculator is you actually have to notice that the square root symbol is above the squared symbol. So then on this calculator, to access that higher symbol, what we need to do is we're going to go hit second to access the second function, which is all of the blue letters above the dot, above the button rather, and then I'm going to push the button, I'm going to get my square root, and I want 50, and close bracket, and there we go. Okay? So we've got 7 and 1/15, which we made 7 and a tenth, so it's 7.1. The actual value is, this is actually equal to 7.07. So 7.1 is pretty good. Anyone have other thoughts as to where they could have gone with this fraction? Other close-ish fractions that are much more simplifiable. Does anyone have any other ideas where we could have gone? Yeah. The 12ths. Okay. Well, let's take a, so here's how I kind of mean, here's how I want you to think about this. 7 and 1/15. We want to massage the fraction to find one that we can simplify. So 7 and 1/15, well, 1/15 is, well, that's 2/30ths, right? That doesn't really help us, but 2/30ths is basically 3/30ths. Well, 3/30ths is 1/10. So that's, we could think about it going that route. Maybe I don't want to go to 30ths. Maybe I want to go to, is that an easy one to do? No. Actually, I think the 10th suggestion was the best one off the bat. Does the procedure kind of make sense? Should we do another one? Let's do another one. Okay, so I want the root of 79. So the first couple steps are easy. I want to find a value, a perfect square above and below 79. What's the perfect square above and the perfect square below 79? So 64 below. Or is it 64 above? No, 64 below.
Grade 9 students, last call.
And 81 above.
For the nurses for
Okay.
immunization. Any grade 9
So root 79 is going to be
form or
somewhere over here.
to the library.
And what I want to do is I want to take the square root of all three of these values.
To the library. ISP 10. Thank you.
So my values here, I've got 8 and I've got 9. So my square root of 79 is going to land somewhere between 8 and 9. I want to figure out what the fraction is going to be, so I need these two distances here. What's the distance between 64 and 81? 17. And what's the difference between 64 and 79? Sweet. So that means my estimate is going to be 8 and 15 over 17. Well, that's terrible. I want to take that 15 over 16 and I want to manipulate it, massage it, so that I have a fraction here that's a little simplifiable. How could we go about doing that? 15/20ths, if I want to go that route, is 3 over 4. Okay, that's one option. Anybody else have a thought? Leslie, did you have a thought?
I thought the estimate of each would be 18 over 20, which can be simplified to 9 over 20.
Oh, because you want to keep the same kind of ratio. So you said 15 over 17 is going to be similar to 18 over 20, which is, you said 9 over 10?
Yeah.
Okay, any other thoughts? Anybody else? Yeah, Kyle? So you said 15 over 18? Well, 15 out of 15, that's 1. That would bring this just up to 9 then. Then our estimate is 9. We know it has to be between 8 and 9, so that might not be a great estimate. Okay. At some point, you're going to have to do this on your own. So if you're not, trying at least to think something up now, that's going to be a challenge for you. So maybe there's some other options that we can't come up with. So we've got two estimates here. This estimate says, who did the 15 over 20? Who was that? Okay, Daniel, was your estimate. So that's 8.75 then becomes that estimate. Zoom out a little bit, sorry. This estimate is Presley's estimate. 9/10 is 0.9, so then this estimate is 8.9. So these are the two estimates that we have for the square root of 79. Y'all got calculators out. What is the square root of 79? What is it actually equal to? $8.88819. And then it keeps going. So is 8.88819 close to either of these values? It's pretty close to both. It's way closer to 1. So Presley's estimate in this case is the better of the two, but these are still both pretty good estimates.
Rounded the second one, I think 8.8.
Yes, this is 8.88. We're still a little ways away.
Yeah.
But both of these, I mean, if you did either one of these, you would have shown me that you understand the technique. Both of those are good estimates. Comments, questions, concerns? Okay, then we're going to keep going. Flip the page. Am I going to get you to practice these somewhere? I am going to get you to practice them somewhere. Okay, this lesson is actually fairly long, so we're not going to take this much. We'll keep it here. Okay, so that was estimating. We're still estimating. The only difference here is now we're going to take a look at some much larger and much smaller values. When the numbers get really, really big, what am I going to do with 1,535? Or I've got 12,300. Or I've got really small numbers, 0.086, 0.45. What are we going to do with things like this? Now, there are techniques that are going to make our life a little easier here. And here they are. For numbers that are larger than 1, and in this case, much, much larger than 1, we're going to estimate the square root by doing some grouping. We want the group furthest from the decimal point. And then after we've done our estimate, we're going to add a 0 from each other group. Or, actually we're going to say it this way, or, I like this to think of it this way better, move the decimal, you'll see what I mean here, to the right once for each group. And I'll explain what I mean by groups in a second. So let's do an example of a number larger than 1 first, and then we'll do a second one. Okay, so how we're defining groups here is we're going to start at the beginning of our number. In this case, 1,535. We'll start at where the decimal is. And we're going to divide these things into groups of 2 digits. Okay? So we're going to add a decimal place in there. And we're going to go over we're going to hop 2. And these are going to be the 2 groups that we've got here. And I'm going to estimate the group furthest from the decimal point. So our estimate now isn't going to be 1,535. We're actually going to estimate the square root of 15. Well, the square root of 15 is going to be between what 2 whole numbers? Sorry? 9 and 16. Because those are the perfect squares on either side. So the square root of 15 is between 9 and 16. The square root of 15 is not between 9 and 16. The square root of 15 is between the square root of 9 and the square root of 16, which means it's between what 2 values? 3 and 4. Good. So we're using the same technique we just did. Between 3 and 4, the distance is... Sorry, no, I lied. Between 9 and 16, the difference is 7. And between 9 and 15, the difference is... So that becomes our estimate, 3 and 6/7. Well, that's weird. 3 and 6/7 is, we don't know our sevenths fractions, so let's massage this thing. Let's make 3 and 6/7 3 and what? What's a nice fraction that we can... What about 8? Like making it 6 over 8? Okay. Because 6 over 8 is what? Or 3 and 6 over 8 is what as a decimal number? 6 over 8 is 3/4. So it's going to be 3.75. Good. So we're going to start with 3.75. And my instructions said move the decimal to the right once for each group. So I've got a group here that I skipped. Only one though. So I'm going to move the decimal once for that group that we skipped. So our estimate then is going to become 37.5. That's not a terrible estimate, maybe? I don't know. Someone grab a calculator. What is the exact value of the square root of 1,535? So 39.18. So if we do some rounding here, the square root is basically 39, and our estimate's basically 38. That's pretty good. When the numbers get really big, being out only by 1 is not terrible. Comments, questions, concerns on what just happened there? Okay, let's do another one. There are no questions. I want to estimate the square root of 12,300. Danny.
So for number one, you could double check your work by like doing by hand, like 37.5 times 37.5.
Yes.
And then could you, like, depending on what that equals, could you?
It equals 1,406.
So could you like add a certain amount to each to get a more? That doesn't make sense. Like take
No, it only
that answer as the
when you're
top.
dealing with square roots, because of the way the square root operator works, multiplying, like, these two values are close, but their squares of these two values is going to be much further apart. Like, these numbers only differ by just under 2,
Yeah.
but their squares differ by over 100.
So that's the most, like,
So this is the technique.
that's the best estimate.
And the way to check it is by actually pulling out a calculator and finding out what the actual square root of that thing is.
Okay.
Cool? Okay. Do another one. 12,300. We start at the beginning of the number. This is actually going to be a really nice one. We make a group. We make a group. So I've got 3 groups here. My first group is 1. Or sorry, my furthest group is 1. So now we're going to use the square root of 1 to be our estimate. The square root of 1 is? And how many groups did I jump? I skipped 2 groups, so I'm going to add how many? What am I going to do with my 1 here? I'm going to take a decimal, I'm going to move it 2 spots, I'm going to fill that in. So my square root estimate is 100. It's nice and easy. Someone grab a calculator. What's the actual square root of 12,300? 110.9 what? 905, so 110.9. When I'm dealing with a number like 12,000, for the square root estimate to be out by 10, that's actually not terrible. Cool? Okay, one more thing I'm going to show you with estimating, and then we'll call it for the day. We'll assign you some stuff, and we'll see how you do with it. For numbers less than 1, we want to estimate the square root of the non-zero group closest to the decimal point. And we're going to add a 0 after the decimal place. Well, actually, we're not going to add a 0. Scribble out that last line. We're going to move the decimal. One to the left. For each group, we jumped. Okay, so this one's a little bit different. The nuances are subtle, but they're there. I want to find the square root of 0.086. So we're going to start at the decimal, and we're going to go make our groups of 2. And we're going to estimate the square root of the non-zero group closest to the decimal point. So in this case, it's right there. So the value then we're going to estimate is just that first group there. So we're going to estimate the square root of 8. 8 is between what? 2 perfect squares? 4 and 9. Square root of 4, square root of 9, which means our value is going to be between 2, and 3. The distance between 4 and 9 is? And the distance between 4 and 8 is? So our estimate for the square root of 8 is 2 4/5 is what as a decimal? I heard someone say 2.8. That's correct. Now this is where things get a little bit different. It says move the decimal 1 to the left for each group we jumped. Technically speaking, how many groups did we jump here? We jumped one group, and we estimated that group, but we jumped one group. So I'm going to move my decimal 1 to the left for that group that we jumped. So our estimate then is going to become 0.28. So I'm on my calculator. What's the square root of 0.086? Danny? Sorry?
2.935.
No, the square root of 0.086.
Oh, sorry. Yeah, sorry. I said 0.29. 0.29.
0.29?
Yeah.
It's a pretty good estimate. Do I need to do more? Are we kind of getting it? Should we do one more? Okay, let's jump down here to number 6. Let's see what happens with 6. Okay, so another decimal number. We're going to go estimate 0.0067. So I'm going to go 1, 2 to get to this first non-zero group is 67. So we're going to estimate the square root of 67. The square root of 67 is going to, or sorry, 67 is between what two perfect squares? 64 and 81. So our answer is going to be somewhere between 8 and 9. We've already done this one, I think. The distance between 64 and 81 is 17. And the distance between 64 and 67 is 3. Well, 3/17, that's terrible. So anyone have a thought where we could go with this? Say that again. Oh, hold on. I heard a different one up front here. Nika, was that you? 4/16. 3/17 is close to 4/16. I like that. 4/16 is going to give me 8.25. How many groups did I jump here? 1, 2. To get to the back of the group that I estimated, I went two groups. So I'm going to move my decimal place twice, which means my estimate is going to be 0.0825. What is the square root of 0.0067? .081. That's pretty good. Okay. Here's your homework. You don't have any class time to work on it. I apologize for that. But here's what you're going to do. I want you to flip the page until you find, you're going to pass a bunch of blank ones, until you find this one here. It says worksheet 9-1-4. Here's what I want you to do. I want you to do up to here. Right there, just to the end of part 4 there. For part 3 and part 4, there's a lot of questions there. I'm going to tell you right now, I want you to do odds for both those two. So you're going to do all of part 1, you're going to do all of part 2, those are nice and short and easy. Part 3 and part 4, you're just going to do the odd numbered questions. So 1, 3, 5, and 7. And then this one's got a 9 and an 11. That's what I'd like you to do for homework tonight. If you got any questions, we'll take them up tomorrow. May the force be with y'all.
I have one for my phone case. At my phone case, a tornado just out of the indigo, and my life is right in here. I don't know how it all fits. There's two on both sides, and one's like a key changer. Yeah, it's like the other way. Yeah, the gift card says this away. Whoa, no. My brother kept it. I need one. I need one. I'm gonna buy.
Okay.